Lately, I've been thinking.
I wanna learn geometry. I want. And fifth period comes, Colin checks the homework done, and then we concluded the answer, not the errors we begun. Every equation, every variable we can take back. Cause with all that has happened, I think we don't know the way that this for a second. I want to change my mind, cause this just won't feel right to me. I want to raise my hand, I want to get it right back. That would mean I had to speak. Lately, I've been thinking. I wanna learn geometry, but it's time for the test. And I'm left here
In the image of seeing the process of preaching and trigonometry. But we run off course. We pretend that we're okay.
If we jump back to the equation, we can solve it in our own way. Not only for a second. I want to change my answer. This just don't feel right to me. I want to raise my hand. I want to get it right back. No, that mean I'll have to say. Lately, I've been thinking. I wanna do geometry. I wanna do geometry. So I'll learn. So the real life uses of SOHCAHTOA, otherwise known as sine, cosine, and tangent, are help people to understand unknown variable with having one variable that is known. For example, if you want to know a height of a building and you have the angle of elevation and you have the length of the base where you're standing from the building, you're able to calculate the elevation of the building by using SOHCAHTOA. Like the different applications are used to find different lengths, such as you could use that to solve basic calculations as height, solve basic in architecture, people use in architecture to find the length that needed for the building to support itself, and it is very helpful. So mainly the SOHCAHTOA is used in architecture and engineering.
Good morning, class. My name is Brian. Today we will be learning the fundamentals of trigonometry and how we can incorporate sin, cosine, and tangent. First and foremost, before we begin, we need to know sine, cosine, and tangent. And in order to do that, there's an abbreviation for it, which is SOHCAHTOA. So first, we will start off with opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. Now, if we look further into this problem, number one, it's asking for the cosine of this angle, the sine of this angle, and the tangent of this angle. So, in order to see cosine, you look up here. So, adjacent of the angle would be 6, and the hypotenuse would be 10. And then the sine would be opposite, which would be 8. Over hypotenuse, which would be 10, and then tan would be opposite over adjacent, so 8 over 6. And we could simplify this by doing the 2, so it would be 3 over 5, 4 over 5, and 4 over 3. Now, in order to solve for the x, you need to do the invert of what it's asking. So you need to first look from here and see what's given. So you're given the hypotenuse and you're given the opposites. So this one will be sin. So you use the inverse of sin and you plug it in, which will be 5 over 14. And then you go in here, second, go to the inverse, and then you plug in 5 over 14, which would be, so you should get x to equal 20 0.92. Moving on, you see that opposite is given as 8, and you're given the adjacent. So you're looking for opposite over adjacent. This would be tan. So you need to find the inverse of tangent, which would be opposite over adjacent. So 8 over 5, which would be you should get x to equal 58. And for the next problem, is the x is right here, same thing. So you're giving adjacent and hypotenuse. So this one will be cosine, which would be cosine, which is adjacent over hypotenuse. So 9 over 13, and then go to the inverse, which would be, you should get x to equal 46.2. And that will be all for trigonometry.